A single graphite filament is invisible to the naked eye. It drifts like smoke. It weighs almost nothing. It lands on a surface and lies there, inert, until electricity finds it. Then it becomes something else entirely. When thousands of these filaments fall simultaneously onto electrical infrastructure, onto transformer housings, radar arrays, circuit boards, air defense control units, the physics takes over. Graphite is conductive. Current flows toward it. Overheating begins. Fail-safes trip. Systems cascade offline in sequence. The power disappears. And it does all of this without a single explosion reaching the target. Ukraine has loaded this physics into its mid-range drones and is now delivering it into the Russian-occupied rear of Donetsk. The weapon is not new. The delivery system is. And the delivery system is what changes everything. What follows is the complete engineering analysis of Ukraine's graphite bomb campaign, what the filaments actually do at the atomic level, why drone delivery is superior to cluster munition delivery in this specific operational context, why Russia's air defenses make the problem worse for Russia rather than better, and why the FP-1 and FP-2 platforms that Ukraine is reportedly using represent only the beginning of what graphite delivery could accomplish at the strategic level. The analysis extends to the FP-5 Flamingo long-range drone with its 3,000-kilometer range, and what graphite payload means when the delivery vehicle can reach anywhere inside Russia. But the physics begins with the filament, and with the precise mechanism by which something this small can take down something this large. Graphite, a crystalline form of carbon, conducts electricity. This property is well documented in material science and has been exploited industrially for decades in applications ranging from battery electrodes to electrical brushes in motors. In the context of a weapon, this conductivity becomes a destructive mechanism when graphite is dispersed in filament form across electrical infrastructure. The mechanism operates in 3 stages. In the first stage, filaments land on exposed electrical components, insulation gaps, conductor surfaces, cooling vents, and transformer housings. Individually, a single filament conducts negligible current. In the second stage, as filaments accumulate across a surface and current flows through multiple simultaneous paths, localized heating begins. Thermal management systems designed for normal operating loads are overwhelmed. In the third stage, the cascade, the heat generated by early filament conductance, causes individual filaments to vaporize. Vaporized graphite creates ionized channels through which significantly higher current flows. These ionized pathways generate arc events. Protective circuits trip. Systems shut down in sequence as their thermal and electrical protection mechanisms activate. The entire process, from filament deposition to full system shutdown, can occur within seconds of sufficient filament density being reached. The critical engineering insight is that this cascade mechanism operates regardless of whether the delivery vehicle reaches its target intact. A drone carrying graphite filaments that is intercepted by Russian air defenses and detonated in the air still disperses its filament payload. The explosion that destroys the drone also releases the filaments, which then drift downward under gravity and wind, landing on whatever electrical infrastructure lies beneath the intercept point. Russia's air defense operators are, in effect, distributing Ukraine's weapon over their own equipment when they successfully shoot down the drones. According to Defense Express, this is precisely what Ukrainian video footage appears to document: debris from intercepted drones, showing graphite filament material, confirming that intercept does not neutralize the payload. Quick note, you're watching DefenseWire. If you haven't subscribed yet, now's the time. The delivery innovation that Ukraine has introduced, replacing traditional cluster munition dispersion with drone-borne warheads, solves a specific operational problem. A conventional graphite bomb, as employed by the United States Navy in the 1991 Gulf War via Tomahawk cruise missiles, or by NATO in its 1999 campaign against Yugoslavia, is a cluster munition containing several dozen submunitions, each filled with graphite filaments. The coverage area is large, the dispersion is rapid, and the effect is immediate. According to The Guardian's reporting from May 1999, NATO's graphite campaign against Yugoslavia achieved 70% power disruption across Serbia in a single engagement sequence, taking with it radar networks, military communication systems, and the air defense infrastructure that had previously been capable of shooting down a U.S. Air Force F-117 Nighthawk. The limitation of this delivery method is the launch platform cluster munitions require aircraft or long-range cruise missiles, both of which are expensive and risk-exposed assets that Ukraine holds in limited numbers. Ukraine's FP-1 and FP-2 mid-range drones, as identified by Defense Express, operate in the same range band as Ukraine's broader mid-range strike campaign, the 20-to-1 50-kilometer corridor behind the contact line that Ukraine has been systematically targeting with escalating strike frequency since early 2026. Loading these platforms with graphite warheads instead of explosive warheads requires no fundamental change to the drone's airframe, navigation, or launch infrastructure. The swap is at the warhead level. This means Ukraine can integrate graphite delivery into existing sortie packages without dedicated launch aircraft, without exposing higher-value assets, and without providing Russia any visible indication from launch signature, whether an inbound drone carries graphite or high explosive. The ambiguity itself is operationally valuable. Russian air defense operators cannot prioritize interception based on payload type. The target set that graphite affects in the Russian-occupied rear is architecturally significant. According to the Kyiv Independent, Ukraine conducted 492 strikes against Russian air defense infrastructure between June 2025 and March 2026, with hundreds of additional strikes against anti-access, area denial assets in Donetsk. Graphite bomb integration into this campaign creates a two-phase effect. In Phase 1, graphite drones degrade radar and control unit electronics, tripping protective circuits, vaporizing component insulation, forcing system resets that require manual intervention. During this reset window, Phase 2 begins. Conventional explosive drones and missiles exploit the degraded air defense coverage to engage higher-value targets without interception. By the time Russian maintenance teams restore electronic systems, the physical damage from the follow-on explosive strikes has already been done. The graphite created the corridor. The explosives used it. Command and control facilities represent the second major target category. C. Two centers in the occupied rear run on electricity communications arrays, battlefield management screens, coordination networks. Graphite-induced power disruption at C2 nodes produces delayed but compounding effects on Russian frontline operations. Instructions delayed or lost at the C2 level translate to coordination failures at the assault level, where individual units receive conflicting or no guidance during ongoing operations. Russia absorbed over 35,000 casualties in March 2026 alone. Coordination failures that compound attrition in the Fortress Belt engagement zone represent a force multiplication effect for Ukraine's existing defensive doctrine. The strategic extension of this capability sits with the FP-5 Flamingo. This long-range drone platform, with a confirmed range of approximately 3,000 kilometers, places targets across Russia's Western industrial and energy infrastructure within graphite delivery range. Power stations, chemical processing facilities, and civilian energy grid components are all vulnerable to the same physics that affects military radar systems. The conductivity cascade does not differentiate between military and industrial targets. Critically, graphite-induced power disruption causes no permanent structural damage. The infrastructure remains standing and repairable after the filaments are cleared and tripped components replaced. Ukraine's graphite campaign into Russia proper would produce recurring blackouts without permanent destruction, a sustained pressure mechanism that is reversible from Russia's perspective but continuously disruptive. Ukraine, which produced sufficient graphite to rank as the world's fourth largest graphite producer between 2022 and 2024, even with its main mine temporarily closed, and which holds estimated reserves of 17.9 million tons, has no supply constraint on this weapon. What the graphite bomb represents in doctrinal terms is the introduction of a non-destructive power denial capability into Ukraine's existing strike architecture, one that compounds the effectiveness of kinetic strikes, degrades the defensive infrastructure protecting Russian assets, and simultaneously preserves the Ukrainian-built electrical infrastructure in occupied territories for post-occupation recovery. The physics of graphite conductivity is not new. Ukraine's operational integration of that physics into a drone deliverable warhead that works even when intercepted is... If you want to understand how Ukraine's broader mid-range drone campaign has evolved alongside the Graphite capability, check out our strike architecture analysis. And if you want to see how Graphite bomb integration reshapes the Fortress Belt engagement picture, our Donetsk tactical breakdown will give you the complete picture. Subscribe to DefenseWire so you never miss what comes next.